Okay, live session will start. Power system protection. Rotate device, it is asking like that. Okay. We'll provide like this. Okay. It's not visible. You have to rotate the screen. Okay. Now, what is relay? What is the principle of relay we discussed in previous classes? The relay is a protective device which detects the fault abnormality condition in the power system, in a bending power system. The relay may detect the fault. You already know that. A protective relay is a device that detects the fault and initiate the operation of circuit breaker. For operation of a circuit breaker, the relay will give initiation to circuit breaker. Now, the fundamental requirements of protective relay will be requirements of the good relay. Requirements for a good relay. What are the requirements for a good relay? First we have to choose particular relay. What are the requirements we require for a good relay? A good relay works very faster. You know that some qualities are required for every relay. The one of the first functional requirements are requirements for a good relay. What are the requirements it is? There is a certain important certain important characteristics are required. What are the good requirements for a relay? Suppose if any fault occur in any substation or any transmission line, other than that, if the relay is too late operate, if the relay operated very slowly, then what will happen? Total entire transformer will damage. In any substation, if any small occur in transformer, the minor fault has to be detected, that has to be rectified. If the minor fault continues for longer time, what will happen? The transformer may be damages. Similarly, in houses also, in power system also, the relay has to detect the fault very fastly. That means which part of the power system gets affected. That is, selectivity is the one of the requirement, good requirement. Selectivity and sensitivity, speed, selectivity, sensitivity, speed and reliability, and simplicity. It is visible or not? Is it visible? Selectivity, sensitivity, speed, reliability and simplicity, and another one is, sixth one is economy. For a good relay, what are the characteristics it requires? That we have to remember. For any good relay, what are the characteristics? Selectivity, sensitivity, speed, reliability and simplicity and economy. These are the good requirements, functional requirements, fundamental requirements also. These are fundamental requirements for a good relay. Selectivity means which part of the power system gets affected, that particular part only it has to remove. A relay detect the fault means, in the sense, if a fault occur in some way, assume that if a fault occur in Vijayawada, then if the relay operated in the Hyderabad, then what is the requirement? If a substation is there in Vijayawada, if the relay operated in Hyderabad, what is the requirement? That means selectivity is the important. Which part of the power system gets affected? In which area it is affected? If any fault occur in some other substation, if you trip another substation or in any relay, then what will happen? This will get damaged. That means selectivity is which part of power system gets affected, that has to be disconnected. That means selectivity is the first major category. It has to select where the fault occurs. For that purpose, we divided entire power system into so many parts. What is you can see, we are dividing the entire power system into so many parts. One is transmission generator side, a low tension side, switchgear, higher transmission line, and distribution side. Like that we are dividing. We can divide. That is low voltage switchgear protection. It is low voltage switchgear, LV or low tension, and high tension transmission. All will be done in high tension. That is power transfer protection. It is transmission line protection. It is power transformer protection. Like that also we can use. And we are dividing entire power system into so many parts. Based on that, if any fault occur, on that relay will be. Similarly, you can see high voltage switchgear protection. It is high voltage switchgear protection, low voltage switchgear protection, and power transformer switchgear protection, and high voltage switchgear protection, high switchgear high transmission line means transmission lines protection. Transmission line protection. After that, selectivity, speed, sensitivity, reliability, most simplicity. These are there. We are dividing so many parts into power system into so many parts. After that, we are providing the relays. Then what will happen? According to if any fault occur in transmission, the distribution side will relay not operate. This relay will operate. We are setting the time also. If any fault occur in distribution system side, if any fault occur, that if the fault not cleared in distribution side, transmission side, or substation side, that is the power transformer side, substation low. In the substation we have relays. Those relays will operate. That means selectivity is the selecting the which part of the power system gets affected. That is the selectivity. Now we go for sensitivity. The relay has to operate very fastly, and the speed also. If it delays the operation, then what will happen? If the speed is delayed, if the relay is not operated for very fastly, what will happen? Entire costly equipment may be damaged. The speed also important criteria for a good relay. Typically, the relay speed will be electrical apparatus may be damages if they are made with carry the fault current for a long time. Sensitivity and reliability. Reliability means, in the sense, the relay has to operate effectively and most reliable. Reliability means it has to work properly. That is, for a long time it has to operate. And simplicity in the sense everyone should understand what is the where the relay works, how the relay works. If the relay circuit is complicated, then everybody need not understand. If you want to construct a relay, that has to be understood by every person. Hence it is known as simplicity. Simplicity in the sense the relay wiring and all will be understood by everyone. If you construct a relay, then the simplicity is the most important. Okay. And economy, the cost of the relay also should be low. That means everybody has to purchase that. That is, these are some fundamental requirements for a relay: selectivity, sensitivity, speed, and reliability, simplicity, and economy. These are the fundamental requirements for a relay. The ability of a relay system to operate with a low value of activating voltage, that is known as sensitivity. The sensitivity means that the relay current, if it is reduces, then the sensitivity will increases. It has to operate within the less span of time. That is low value of quantity. Suppose 1000 amps is the rated current. It has to, when the fault current reaches to more than 1000 amps, it has to operate. If it is delay, what will happen? The relay will won't work. These are the fundamental requirements for a good relay, for a construction purpose, for selecting purpose, for understanding purpose. All this will be. Now we go for electromagnetic relays. What is relay? What are the requirements of relay? Good relay. Some basic requirements of says simplicity, economy, and speed, reliability, simplicity, economy. Those are the fundamental requirements for any good relay. Now, what are the types of relays? Types of relays. What are the various types of relays that we will discuss now? Basic relays, what are the types? Already in the last class we told that what is the relay. There are two types of relays. One is basic relay. Nowadays we are using microprocessor based relays, but what are the basic relays? Electromagnetic relays, electromechanical relays. Those are electromagnetic relays. Most of the relays on the power system operate by the current or voltage. Electromagnetic relays, these are classified types of relays. One is electromagnetic attraction relays and electromagnetic induction relays. Basically, the relays are classified. Already I told you in the last class, the relays are classified into three types. One is electromechanical relays. Electromechanical relays. And second one is static relays. Those are classified. Electromechanical relays, here we are using plunger and coil and moving parts will be there. Electromechanical motion controls the circuit breaker. In static relays there is no rotating part. What is static relay? It consists of solid state devices like diode, transistors, and rectifiers like that. Comparators, all will be used in static relays. And another one is microprocessor based relays, or we can say that microprocessor based relays. Basically, these are the classification. Microprocessor based relays. Okay. Electromechanical relays, first we will go for it. First one is electromagnetic induction relays, electromagnetic attraction relays. First we go for this one, electromechanical relays. These are electromagnetic attraction relays. These are classified. The basic relays, electromechanical relays are classified into types of relays or basic relays. It is also known as. The basic relays are classified into electromechanical, static, and microprocessor. Now these electromechanical relays are classified into electromagnetic attraction, and second is similar way electromagnetic attraction and induction principle. It works on the principle of attraction of Electromagnet attracts the plunger. Previously what we told that it has a coil, a plunger will move inside. This plunger close the circuit, you told in the last class. When it is the coil, it consists of number of turns. Then we are giving the this is the for this coil. Whenever fault current reaches maximum current, then maximum flux will be produced. Due to this, it acts as electromagnet. It moves downwards. That is electromagnetic attraction relays. It attracts the plunger or armature. It is the moving armature that is attracted towards the coil. That is electromagnetic attraction relays. Attraction principle we are using electromagnetic attraction relays. These are solenoid type relay and balanced beam relay. Two types of relays are there. Electromagnetic attraction relays are balanced beam and solenoid type relay. Similar to induction relay. Electromagnetic induction principle we are using. Similar to induction meter, induction energy meter. What is the meter using induction principle is induction motor is the induction principle. The meter which uses induction principle is energy meter. The energy meter, single phase induction type energy meter or three phase induction type energy meter works on the principle of induction. It is similar to induction type energy meter. This what is electromagnetic induction relay? Electromagnetic induction relay similar to energy meter. Energy meter construction, you know, it consists of a pressure coil and current coil. A current coil is connected in series with the load. A current coil is connected in series with the load. You can see. And this is connected in series and pressure coil is connected here. A aluminum disc is rotating. That is the energy meter. The same for the energy meter. For the disc we are attaching one contact, NO-NC contact. These terminals are connected to circuit breaker. These two terminals. Induction principle. The disc continuously rotates. Whenever fault occurs, the disc try to rotate. Under normal conditions, the disc will be in operative condition. That is the induction type, attraction type relays. One by one discuss next class. Okay. Basic relays are classified electromechanical, static and micropulse. Electromechanical devices are relays due to electromagnetic attraction and induction. These are classified. Attraction relays are solenoid type, balanced beam type relays are there. How they are working? So balanced beam, solenoid means the number of turns are there. In between the plunger will be moved. It is like similar to solenoid type relay and balanced beam type relay. Two types of electromagnetic attraction relays are there. These relays works on the principle of attraction. Whereas induction relays works on the principle of induction. Similar to energy meter. One by one we will discuss in the next class.